Okay, as the sentence states that it's an mechanism of, it's an mechanism of, just a second. Okay. Okay. So now mechanism of nucleophilic substitution reaction. So mechanism means we know that it's an in detail study of and reaction. ಒಂದು reaction in detail study. So ಹೇಗೆ bond break ಆಗುತ್ತೆ, how the bond will break, how the bond will flexibilate, which one will remove first, then which is replace that, or if addition, what is the conditions that we need to apply. So the in detail study of the reaction is called mechanism. Nucleophile means the substance which having more electronegativity than your carbon. So ಯಾವುದೋ ಒಂದು ಆಟಮ್ ಅಥವಾ ಸಬ್ಸ್ಟೆನ್ಸಸ್ ಕಾರ್ಬನ್ ಗಿಂತ ಜಾಸ್ತಿ electronegative idre, so that is called it as nucleophilic. Then substitution means we are just exchanging in between those. So suppose I have two things, so one is hydrogen and one is hydroxide. So I'm just replacing the hydrogen in the position of your hydroxide. Okay, hydrogen na hydroxide iro jagake change ಮಾಡ್ತಾ ಇದೀನಿ, so that is called substitute. So we have one thing called, right? So if the one faculty is not present at that day, so we have another one that is called substitution. So in the position of the original, we are replacing one more, so that is called substitute. So what we are doing in the reaction, we are adding, we are just replacing the position of the electronegative component. So in the, it means to say that we are removing the less electronegative atom and we are adding more electronegative atom. Okay, is that clear? So now let us start. What you need to do first, in this mechanism you have two types. One is SN1 mechanism, second one is SN2 mechanism. Okay, so in the nucleophilic substitution reaction you have two SN1. So substitution of nucleophilic biomolecular. So you have SN1 and SN2 mechanism. So SN2 antandre, it's an SN2 means substitution of nucleophilic reaction, of bimolecular. Bi means two. Okay. So in between two molecules, we are replacing. SN1 and it's also a substitution, same substitution reaction of nucleophilic reaction of unimolecular. Unimolecular. So it's one atom replacing, that is called SN1. The more important in between SN1 and SN2 is your SN2 mechanism. So you have little bit of importance for SN2. Actually, frankly speaking, both are very, very important. This is compulsory question for 3 marks. So 3 marks in a compulsory question. Either they could have asked SN1 mechanism or they could have asked SN2 mechanism. So first, let us read SN2 mechanism. So it is also called as hydrolysis of methyl bromide. It's also called as hydrolysis of methyl bromide. Okay. So now, when methyl bromide is heated with aqueous potassium hydroxide solution, okay, when methyl bromide is heated with aqueous potassium hydroxide solution, methyl alcohol will form. So when methyl bromide and ಹೇಳಿದ್ರೆ, so it is of CH3Br. When methyl bromide heated means sunlight ಕೂಡ ಬರಿಬಹುದು ಅಥವಾ heated temperature H ಹಿಂಗ್ ಬರೆದ್ರೆ heated. So with aqueous potassium hydroxide ಅಂತಂದ್ರೆ KOH but dissolved in water. So that is called KOH. Potassium hydroxide is water, that gives you an aqueous KOH. So when these two are reacted, we'll get the product of just, and as usual, you just replaces the plus and minus symbols, then you will get answer very easily. Plus KBr. Idu methyl hydroxide ಅಥವಾ methanol, methyl alcohol, METHANOL, methanol, and potassium bromide. ಹೌದಲ್ಲಪ್ಪ, potassium bromide. Okay. So this is the reaction of SN2. So now we need to know that how easily it will remove and how can the OH will replaces it. ಇವಾಗ BR place ಗೆ OH ಬರುತ್ತೆ ಅಂತ ನಮಗೆ ಗೊತ್ತಾಯ್ತು. So we know that BR is replaced by OH and we need to prepare methanol, that is methyl alcohol. Yes, we'll agree. But we wrote in one line, does it so easy? So how we made, does it so easy like we can remove one and we can add one? No, it's not easy. So if you read how it happening, that is called as mechanism. So let us write the thing here. So this is CH3Br. Okay. So this is the structure of methyl bromide. So what I will do, I'll just change the position of the structure. So because if it seems to be flexible and movement, it will keep on moving aside. Okay. So what happened when OH, okay, KOH, because it is aqueous, it will dissolve very easily. KOH is present in aqueous media, so it means to say ionization of potassium hydroxide is very easy. So as soon as we are getting OH, it will come and attack one side of your carbon. OH will come and attack the one side of your carbon, and it will become like this. So if you are notice here, I wrote OH and Br both functional group in a dotted structure. Why? Because when a competition held between an atom with the same functionality, ಅಂದ್ರೆ ಎರಡು ಒಂದೇ ಫಂಕ್ಷನಾಲಿಟಿ ಇರುವಂತಹ ಆಟಮ್ಗಳು ಒಂದೇ ಕಾರ್ಬನ್ ಮೇಲೆ ಎರಡು ಏನಂತ ಕರೀತಾರೆ, ಇಫ್ ಯು ಹ್ಯಾವ್ ಆನ್ ರೈವಲ್ರಿ, ಎರಡಕ್ಕೂ ಒಂದು ಕ್ಲಾಶಸ್ ಸ್ಟಾರ್ಟ್ ಆದಾಗ, ಇಫ್ ಲೈಕ್ which one is more and less ಅಂತ sharp, if it starts at that time, both the atom will lose the direct contact between the ಕಾರ್ಬನ್ ಜೊತೆ ಇರುವಂತಹ ಸ್ಟ್ರಾಂಗ್ ಬಾಂಡಿಂಗ್ ಅಥವಾ ಡೈರೆಕ್ಟ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಅನ್ನ ಕಳ್ಕೊಳ್ಳುತ್ತೆ. ಸೊ ಇಟ್ ವಿಲ್ ಲೂಸ್ ಇಟ್. ಸೊ ಆಸ್ ಸೂನ್ ಆಸ್ ಇಟ್ ಲೂಸಸ್, it will become an weak force of attraction. It's not considered as a bond. ಈಗ ಹೇಗೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಈಗ ಸಪೋಸ್ ಇನ್ ಮಕ್ಕಳು, ನಾನು ಹೇಳ್ತಾ ಇದೀನಿ, I want to give the example in case of kids. So small kids, like if we go for a pre-nursery or nursery, so at that time what happen, if one of the friend will give a pencil or eraser whatever, so until and unless the whatever the friendship donating a pencil ಏನು ಕೊಟ್ಟಿರ್ತಾರೆ, ಆ ಒಂದು ಪೆನ್ಸಿಲ್, as soon as or until that, if both are at the same zone, the things are in between them. ಸೊ ಒಟ್ಟಿಗೆ ಇರ್ತಾರೆ ಫ್ರೆಂಡ್ಸ್ ಆಗಿ, ಅಲ್ಲಿವರೆಗೂ ಅವ್ರಿಬ್ರ ಹತ್ರ ಆ ಪೆನ್ಸಿಲ್ ಅಥವಾ ಒಂದು ಎರೇಸರ್ ಎಕ್ಸ್ಚೇಂಜ್ ಆಗಿರುತ್ತೆ. ಸೊ ಇಟ್ ವಿಲ್ ಸ್ಟೇ ಲೈಕ್ ದಟ್. ಬಟ್ ಆಸ್ ಸೂನ್ ಆಸ್ one of us is met another friend, is giving importance to another one, so at that time, ಈಗ ನಂಬರ್ 1 and 2 ಅಂತ ತಗೋಣ. ಸೊ ಇಬ್ರಲ್ಲಿ ಯಾರು ಒಬ್ರು ಇನ್ನೊಬ್ಬನ ಫ್ರೆಂಡ್ ಮಾಡ್ಕೊಂತಿದ್ದಾರೆ ಅಥವಾ ಅವನ ಜೊತೆ ಜಾಸ್ತಿ ಟೈಮ್ ಸ್ಪೆಂಡ್ ಮಾಡ್ತಿದ್ದಾರೆ, ಅವನ ಜೊತೆ ಜಾಸ್ತಿ ಮಾತಾಡ್ತಿದ್ದಾರೆ ಅಂದಾಗ ಇವರಿಬ್ರು ಮಧ್ಯೆ ಸ್ವಲ್ಪ ಕ್ಲಾಶಸ್ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಸೊ ಆ ಟೈಮಲ್ಲಿ ಬರೋ ಫಸ್ಟ್ ಪಾಯಿಂಟ್, ನೀವು ಅವನ ಜೊತೆ ಮಾತಾಡ್ತಿದ್ಯಾ ಅಲ್ವಾ, ನಾನು ನಿಂಗೆ ಪೆನ್ಸಿಲ್ ಕೊಟ್ಟಿದ್ದೆ ಅಲ್ವಾ, ಗಿವ್ ಇಟ್ ಬ್ಯಾಕ್. ದಟ್ ಇಸ್ ದ ಸೇಮ್ ಪಾಯಿಂಟ್. ಇಲ್ಲೇನಾಗುತ್ತೆ, bromine giving an electronegative support for the carbon, because carbon positive irutte, so hagagi idar electron na kottu balance ಮಾಡಿರುತ್ತೆ. So as soon as the carbon is focusing on the another one, that is called hydroxide, ಯಾವಾಗ ಕಾರ್ಬನ್ ಇನ್ನೊಂದು ನ್ಯೂಕ್ಲಿಯೋಫಿಲಿಕ್ ಜೊತೆ ಅಥವಾ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವ್ ಆಟಮ್ ಜೊತೆ ಇಂಟರಾಕ್ಟ್ ಮಾಡಕ್ ಶುರು ಮಾಡುತ್ತೋ, ಇಟ್ is ಸ್ಟಾರ್ಟ್ ವಿಡ್ರಾಯಿಂಗ್ ದರ್ ಎಲೆಕ್ಟ್ರಾನ್. ಈ ಬ್ರೋಮಿನ್ ಏನ್ ಮಾಡುತ್ತೆ, ತನ್ನ ಎಲೆಕ್ಟ್ರಾನ್ ನ ವಿಡ್ರಾ ಮಾಡಕ್ ಸ್ಟಾರ್ಟ್ ಮಾಡುತ್ತೆ. ಸೊ ದಟ್ ಟೈಮ್ we can't write it in a straight bond line, so we are representing that in a dotted line structure. This is called as transition state. Okay, this is an intermediate state between methyl bromide and methanol. methanol ಗೂ methyl bromide ಗೂ ಇರುವಂತಹ intermediate state. ಯಾಕೆ ಅಂತ ಹೇಳಿದ್ರೆ ಇಲ್ಲಿ ಆಲ್ಕೋಹಾಲ್ ಗ್ರೂಪು ಇದೆ, bromide ಗ್ರೂಪು ಇದೆ. So that's why it is called as transition state. Okay, so as soon as it completes the transition state, it will go to the next state, that is call it as methanol state. Okay, so methanol plus Br minus. So hagadre ma'am, now we have a doubt that already bromine is present and it forms a methyl bromide, that is stable compound. Why we required it, or why we are supposed to change OH? ಯಾಕೆ ಚೇಂಜ್ ಮಾಡಬೇಕಿತ್ತು? ಬ್ರೋಮೈಡ್ ಇರಲಿ ಬಿಡಿ ಮ್ಯಾಮ್, ಸ್ಟೇಬಲ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ನೋ ಪ್ರಾಬ್ಲಮ್, ಎವ್ರಿಥಿಂಗ್ ವಾಸ್ ಫೈನ್. ಬಟ್ if we require to prepare an methanol, ನಿಮ್ಗೆ ಮೆಥನಾಲ್ ಪ್ರಿಪರೇಷನ್ ಬೇಕು, you need methanol. So at that point you can prepare in this method. Yes ma'am, we'll agree. Okay, if you want you can prepare, that is your choice. Yes. So but the thing here, as according to your statement, bromine and hydroxy group both are considered as an electronegative component according to your statement. Yes, of course. Then why when hydroxide came, why bromine leave their place? Why it needs to come out from the carbon? It could have stay with it, no? It could have fight and it could have remove the OH group. ಯಾಕೆ ಅದು ತನ್ನ ಜಾಗನ ಬಿಟ್ಕೊಡ್ಬೇಕು? ಹೈಡ್ರಾಕ್ಸೈಡ್ ಬಂತು ಅಂದ ತಕ್ಷಣ why bromine will get out from the carbon attachment ಇಂದ ಯಾಕೆ ಹೋಗುತ್ತೆ? Why it went off? Okay, so ಅದಕ್ಕೆ ಒಂದೇ ಒಂದು reason ಇದೆ. For that we have only one reason, that is based on more electronegative and less electronegative component. So suppose in the position of ಈಗ bromide replace ಮಾಡಿ hydroxide ಬಂತು. If in case hydroxide ಇದ್ದು, if you can you able to replace that with bromide, like I'm saying reverse of it, ಅದು possibilities ಇದೆಯಾ? Does it happen? ಅಂದ್ರೆ already the formation of methanol ಇದೆ ನಮ್ಮ ಹತ್ರ, so we need to convert the methanol into methyl bromide. Does it possible? No, it's not possible. It's not possible. Why it is not possible? Because why it is not possible ಅಂತಂದ್ರೆ ಬೆಳಕು ಕಾಣಿಸ್ತಾ ಇದೆಯಾ? ಸಾರಿ, ನಾನು ಗಮನಿಸಿರ್ಲಿಲ್ಲ. So why it is not possible? Because more electronegative atom will replace a less electronegative atom. ಜಾಸ್ತಿ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವ್ ಇರುವಂತಹ ಆಟಮ್ ಕಡಿಮೆ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವ್ ಇರೋದನ್ನ ರಿಪ್ಲೇಸ್ ಮಾಡುತ್ತೆ ಹೊರತು ಕಡಿಮೆ ಇರೋದು ಜಾಸ್ತಿ ಇರೋದನ್ನ ರಿಪ್ಲೇಸ್ ಮಾಡಕ್ಕಾಗಲ್ಲ. ಸಪೋಸ್ ನಾನಿವಾಗ ಯಾರತ್ರನೂ ಸಾಲ ಮಾಡಿರ್ತೀನಿ, 10 rupees ಸಾಲ ಮಾಡಿರ್ತೀನಿ ಅಂತಂದ್ರೆ, if I want to cover that, I need to get that money from other. I need more. I can't go for the less amount. ಕಡಿಮೆ ಅಮೌಂಟ್ ನಾನು ಹೋಗಲ್ಲ ಅಲ್ಲ, ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಅಮೌಂಟ್ ಕೊಟ್ರೆ ಅವ್ರ ಹತ್ರ ಹೋಗ್ತೀನಿ. ಸೊ same like that, if more electronegative atom came to the picture, inevitably the less electronegative atom should leave their place. This is the mechanism logic. Okay, this is called as SN2. Sorry, this is SN2 mechanism. So this is very easy. Idu easy ಇದೆ. So you just learn it. SN1 mechanism ಒಂದು ಸ್ವಲ್ಪ ಲಾಜಿಕ್ ಆಗಿದೆ. I'll explain it. So not only for this, you can take the example of whichever you want to take. So ಒಂದು ಕೆಲಸ ಮಾಡಿ, ಇವಾಗ ಇದ್ರದ್ದು ನಾನು ಸ್ಟೆಪ್ಸ್ ಒಂದು ಬರೆದು ತೋರಿಸ್ತೀನಿ. I'll just write the steps of nucleophilic, like SN2 mechanism though. Then you can start with other examples. So ಇವಾಗ ಗೊತ್ತಾಯ್ತಾ why it is called it as bimolecular ಅಂತ ಕರೀತಾರೆ ಅಂತ? Because two molecules of electrophilic substitution are present at a time. ಎರಡು ಒಂದೇ ಸಲ ಪ್ರೆಸೆಂಟ್ ಆಗುತ್ತೆ. ಓಕೆ, okay, you just try. ಇದು ನಾನು ತೋರಿಸಿದೆ ಅಲ್ವಾ, ಮಿಥೈಲ್ ತೋರಿಸಿದೆ. Can you try it for ಸ್ಟ್ರಕ್ಚರ್ ಕೊಡ್ತೀನಿ, ಅದಕ್ಕೆ ಟ್ರೈ ಮಾಡಿ. Will you try for this? Give a try for this structure. ಬರೀ ಇದು Same hydroxide thermony, just write the inter transition state. This is also called as intermediate state. So transition state admele, you just write the product. First name of compound name ಮಾಡಿ ನಿಮಗೆ ಗೊತ್ತಲ್ಲ ಇಂಪ್ಯಾಕ್ಟ್ ನೇಮ್ ಅಲ್ಲಿ ಹೇಗೆ ಮಾಡೋದಂತ. Just write the compound name, then start covering. ಆಯ್ತಾ ಮೇಘನಾ, ಗೋಕುಲ್, Nash? Okay. Now it's simple ಅಲ್ವಾ, ಇವಾಗ ಅದು ಬಂತು, then bromine will went. So ಇಷ್ಟ ಈಸಿ ಇದೆ. But if you read on SN2 mechanism, SN2 ಇದು ನೀವೇ ಕಂಪ್ಲೀಟ್ ಮಾಡಬೇಕು. You should complete this. So SN1 mechanism ಒಂದು ಸ್ವಲ್ಪ, it's not so difficult. When you are comparing this, it seems to be a little bit of difficult. ಒಂದು ಸ್ವಲ್ಪ ಲಾಜಿಕ್ ಅನ್ಸುತ್ತೆ ಅಷ್ಟೇ. So in these steps you have, in SN1 mechanism, two-step reaction. Okay, you have two-step reaction. This is called as hydrolysis of tertiary butyl bromide. This is called as tertiary butyl bromide. So what happened? Tertiary butyl bromide ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ? So here just ಇದನ್ನ example ಆಗಿ ತಗೋತೀನಿ. So as I informed you, this is three-step reaction. So this is called overall step. Same. When tertiary butyl bromide is react with your potassium hydroxide, it will give you an tertiary butanol plus potassium bromide. Okay. So let us see the mechanism stepwise. ನೀವು ಅವಾಗ ನೋಡಿದ overall reaction ಅಲ್ವಾ? Let us see the first step. Step 1. Formation of carbocation. Formation of carbocation. So tertiary methyl bromide ಏನಿದೆ, so here it will form carbocation first. ಹೇಗೆ carbocation form ಆಗುತ್ತೆ? What do you mean by carbocation? The carbon which carries a charge, that is called carbocation. This is formation of carbocation. If a carbon which carries a plus charge upon it, that is called carbocation. Then step 2. Okay, step 2. Attack of nucleophilic on carbocation. So ಈಗ carbocation ಇದೆ ಅಲ್ವಾ, so the nucleophilic go and attack to an carbocation. It will produce tertiary butanol. This is called as tertiary butanol. Okay, tertiary butanol. Fine. So ಇದಕ್ಕೂ ಬೇರೆ ಟ್ರೈ ಮಾಡಬಹುದು. You can try any one example of this. Okay, so these two are very important, and they'll give you write the differences between SN1 and SN2 mechanism. Differences between SN1 and SN2 mechanism. This is 2 marks question, important question. This is your assignment. This is your today's assignment. Write the differences between SN1 and SN2 mechanism. Okay, next step. Let us write the resonance of benzyl carbocation. Resonance of benzyl carbocation. So andre now resonance structure of benzene we have read. So let us write how it happened. Okay, so this is benzyl carbocation, like a CH3 group. If benzene attaches to CH3 group, what do you mean by that? Toluene alla. So ivaga adu positive charge alli idre, so if it is present in positive charge, let us see what happened for that. How the resonance structure will change. ಈ ಬಾಂಡ್ ಕರೆಕ್ಟ್ ಆಗಿ ನೋಡ್ಕೊಳ್ಳಿ. The position of the bond is very important. So while writing a resonance structure, you should write in both direction arrow mark. Arrow mark ಎರಡು direction ಅಲ್ಲಿ ಇರಬೇಕು. ಓಕೆನಾ? So first what happened? This bond will move to satisfy the valency of carbon. Carbon plus ಇದೆ ಅಲ್ವಪ್ಪ? So that's why this bond will move towards the carbon. So when it moves towards the carbon, it vanishes the positive charge and it will become double bond. So double bond adaga, you can see only the presence of 2 bonds inside. So at that time, this carbon carries a positive charge. Ekendre ee carbon ge valency satisfy agiralla alva adike. So again ಮತ್ತೆ ಏನಾಗುತ್ತೆ, ಈ ಕಾರ್ಬನ್ ನ valency satisfy ಮಾಡೋಕೆ this bond will attach to this carbon. So when it gains, okay, when it gains, what happen? You will get the bond over here and another bond here. So because of this carbon get positive charge. Okay, this carbon get positive charge. Again, to satisfy this positive, this carbon will come out and it will become now this is carbocation. This okay. Sorry, the CH2, CH3 Allah, I made a mistake. Now again, it changes. Again, this carbon attaining positive. So, ma'am, ಮತ್ತೆ carbocation bantala? Haudu, but if you see of the structure 2 with structure 1, you will get the differences. There will be a change in the position of the bond. Nodi, bond in a position change agide. Haudalva? There is in the position of the bond. This is called resonance structure of benzyl carbocation. Benzyl carbocation. Fine. Okay, you have then the order of reactivity. Order of reactivity. So which one is more, which one is less? Okay, that is called order of reactivity. So let me take a dance. Complete the reactions. Shall we move on? Continue again, ma? Okay. So the order of reaction, order of reaction of following halides for SN1 reaction. So the order of reaction ಅಂತ ಹೇಳಿದ್ರೆ ಯಾವುದು ಜಾಸ್ತಿ electronegative and which one is less electronegative and which one is more electronegative. Okay, this is lesser than, you just name the compound. Name Matra, can you just name the compound? This is chlorophenol. And what about this? Search Muddy and give the name of this compound. There's homework for you. Okay. Then we'll continue that in tomorrow's class. Bye bye.